Hello, mathematicians. Welcome to another day of learning penny jar situations and taking it to the next level. We're going to start with our warm-up. Remember, you don't need anything for this warm-up because I really want to help you start doing as much of this type of math in your head as possible. Okay, so we're going to do closest estimate. And we're doing closest estimate with this division problem. Okay, so a little erased, but that is when you see it in this division box, remember it's this number divided by the outside number. So that is a motorcycle. Life happens. Let's keep going. That's 611 divided by 12. So when you think of this, first always think of it as, that's right, multiplication. And then once you think of it as multiplication, think about how you could change one of these numbers to make it easier for you. All right? Personally, pause the video and come up with your answer, whether you think it's 40, 50, or 60. Press play when you're ready to see what I did. Okay, welcome back. So if you're thinking like I am, I first going to write it, it just always makes it easier for me to think of it like this. 611 divided by 12, and then 12 times something equals 611. Now when I look at this, I think to myself, well, I know 12 goes into 60, so if I know 12 goes into 60, I'm going to make this 600 because I can use those small facts to help me with the big facts. So 12 times something equals 600, okay? So I just changed this by 11 numbers. Now, I know 12 times 5 equals 60. So if I add the 0 here for 600, then I can add a 0 right here and make it 50. Okay, because 12 times 50 equals 600. So that's pretty close to this answer. So if you got 50, you are correct. And if you didn't, that's okay. But now you have a strategy to, you've seen a way to do it so you can keep it in your head, all right? Using those smaller facts to help us get to bigger facts. Okay, now I want to review a little bit of what we were doing yesterday, or Friday. Yesterday because this is Friday for me and I'm filming this for Monday. Okay, so when we were talking about the penny jar situation, I want you to go back to the page, I believe it's 507 in your book. On 507 in your book, we did a pasta jar or a penny jar situation where we started with 2 pastas and then we added 3 each time, right? So after round 1, we added 5, after round 2, we add 8, and so on and so forth. And you boys and girls wrote down your version of the rule. I saw some students write add 3 every time. I saw some with just like the blank like I had of this would be the number of rounds times 3 equals plus 2 for the starter equals the total. So some of you had like these different strategies on how to get to the answer. And now I want to introduce to you how to create an equation or an expression, they mean the same thing, to represent the penny jar situation for any round, okay? For any round. You could jump to the 10th round, you could jump to the 50th round. You wouldn't have to go one by one to get to round 50 or 80 or whatever you choose, okay? So what we do in math sometimes when there's an unknown, like we don't know how many rounds, but we want to say like this is where you would put in that number. I had put a blank, but actually what we really like to use in math is actually we use letters. Letters can represent an unknown amount or a number to be placed later. We've talked about this a little bit earlier this year. So if you look right now, I have 2 different examples, okay? So first I had the R, so I did 3 times R plus 2. So think to yourself, what could each part represent from that equation I just talked about? Starting with 2 pastas or pennies, adding 3 each round. Yep, that's right. So the 2 is definitely the pastas we started with. The 3 is how many we add each round. But it's multiplication because it's times the number of rounds. So I chose R because it's the round. So it's not the rounds of the amount of times I've put in pasta, okay? Now, let's say you're like, I don't want to use R, I want to use a different letter. You always want to choose a letter that's close to the meaning of what you're representing just because it'll stay, it'll be easy for you to remember, okay? So here I also chose N. Now, N I chose because it's the number of rounds. I want you to pause the video and think about, look at these two equations. What do you see as the same and what do you see as different? Press play when you have figured it out. Okay, welcome back. So here, what I've noticed is the same is, well, we have the starting with 2, that's right there, and we have the starting with 2 that's right over here. So those numbers are the same. We have 3 times something and 3 times something here because it's for the same equations, for the number of rounds when you start with 2 and you add 3 each round. But what I did notice was the multiplication part is in the beginning of this equation right here, and here it's at the end. That's okay. It doesn't really matter which order it goes in, because when you're adding 2 to some number that's multiplied, it can come at the end and it can come at the beginning. It's not like division and subtraction where you could really get a different kind of answer. Okay? Now, if we wanted to make this even more clear for our for whoever is doing this problem, or whoever we give this to, we have something that we don't have to use it, but it can be very helpful in math, and we call those parentheses, okay? So I tend to put parentheses around what I multiply, okay? Because it helps keep, like, it tells the person doing the problem, like, do this first, okay? So you could also do 3 times r plus 2. Because if I did r plus 2, if I did the parentheses right here, it would say the rounds adding 2, that whole number, times 3. And that would be, you'd be adding like 2 to every single round instead of just the first one. So it wouldn't really be a starting with number. It'd be giving you a whole different answer. Because like if it was the first round, right, it would be a 1 right here. And it'd be 1 times 3 is 3 plus 2 is 5. And that's what we knew is round 1, we had 5. But if I had the parentheses here, it would mean to do this first. So it would be 1 plus 2, which is 3, times 3, which is 9. So you see how round 1 would have the incorrect answer if you put the parentheses around the wrong part? Okay, so can you predict where the parentheses will go for the second equation that demonstrates the same penny jar situation? That's right. Okay, I hope you said it would go around 3 times n. So you see, you can have that plus 2 at the end, or plus 2 plus in the beginning, and it doesn't really matter because when you're adding, it can come at any time, just as long as it's not being confused with multiplication, like what you're multiplying. Okay. All right, now we can take it even a step further. Now I wish we were all together right now so we could really discuss like what letter would you choose and what letter would I choose, but I can just give you the suggestion of stay away from the letter X and stay away from the letter 0 or O, because an O can look like a 0 and that can be very confusing, and an X can be confusing because that's right, because when you multiply, we're using an X right there, so we don't want to confuse which one we mean. So that's why it's good to stay away from those two letters when you are doing this kind of equation, where it's called algebraic equation, but it's an expression to represent a situation. So now looking at it like this, I can think to myself, I can jump to the round I want. I don't have to start from round 1. Going plus 3, plus 3, plus 3, plus 3. Let's say I want to do round 30. All I have to do is put a 30 where the R is. So instead of writing R, I would just go 3 times 30, because that's the 30th round I want to find out. That would be 90, and then 90 plus my starting 2 would equal 92. So on my 30th round, I would have 92 pennies or pastas, okay? So you just put the number of the rounds in place of the letter, and you can jump to whatever round you want, okay? So right now I'm going to give you a different round. So what about if we did 50, okay? What will we get on the 50th round? So look at this one. It's the same equation, just, you know, one is in the beginning and one is at the end of where the multiplication is. But how many pennies will we have after the 50th round? Pause, figure it out, doing what I just did, and then press play to see. Okay, welcome back. So if you said 3 times, and you put the 50 because that's the number of rounds, and we're on to the 50th round, and you got 150 from that times 3 plus that 2, and you got 152 pennies. You're so right. Good job, mathematicians. And if you didn't, then like you learned something with me, and that's my job to teach. Okay. Okay, what if we wanted to add another letter in there? Where would that letter go? I'll show you. I'm going to erase my purple right here because I want to stick with these equations to show you where you would have another letter. You can use another letter to show what the answer would be. So there can be the unknown of the round, like which round you're on, and then there can be the final answer. So if you wanted, let's say you wanted to do equals T, and you would have to have a key to say R equals the rounds and T equals the total. You would have to tell your whoever's doing your problem which each letter represents, but this would be correct. You could have it equal to T because it's equal to whatever your unknown is, your total amount of pennies or pastas in the jar. So when we had a 30th, so you could say when R equaled 30, right? We said the 30th round. How many pastas or pennies did we have total? We had 92. Remember that? So you can say like when R, or the rounds, equals 30, T will equal 92 because that'll be the total, right? That's the answer we got. Okay, it's just another way to say the answer using it as a letter. So here, if you're like, you know, Miss Thompson, I don't want to use a T, I want to use a different letter. And I'm like, okay, do you want to do, and they're like, I want to do P. I'm like, oh, is P for pennies or pastas? And notice that like the letters are connected to what they mean. It can be, they don't have to be, but it can be very helpful to keep track. Okay, so yeah, totally. P could be when this was 50, right? When we were on the 50th round, it was 50 times 3 equaled 150. Plus 2 was 152. So P was 152 total pastas or pennies. Now, I'm going to maybe throw you for a loop here. I mean, I might confuse you, but stick with me. You can do this, okay? So I just needed a little bit more room. That's exactly what was written before. Nothing has changed. But what if instead of writing equals P right here, I put like this? Excuse me. Let me just write it. What if I put it at the beginning? P equals 2 plus 3 times n. Wait, I thought the answer was always at the end. Well, what does the equal sign mean? Okay, it says it equals the answer, but what it really means is both sides, if both are equal, right? Both are the same, okay? They're both the same. So if P equals, as we were just talking about, if P comes out to being, so we're saying, okay, if this is 50, we're on the 50th round, and we're timesing that by 3, so that's 150 plus 2, then this side equals 152, right? And if this side equals 52, then P also equals 52. Because the equal sign, all it means is both sides are the same, right? So if I wanted to, if that feels confusing to you, just remember, you can do this, right? 6 equals 2 times 3, and you can have the answer in the beginning, or you could go like this. Now, why does that make sense? Okay, well, think about it. Whisper it to yourself. Okay, and if you're thinking to yourself, well, because 5 plus 1 equals 6, and 2 times 3 equals 6, and the equal sign just means both sides are the same, then yeah, 6 and 6, it's the same number. They are the same. So it's 2 different ways to find 6. So when you have the equal sign, you can have it at the beginning, or you can have it at the end, because all it means is both sides of the equal sign are the exact same amount or the same value, or, you know, but same, okay? So we're going to be playing around with that today in our math, okay? So I'm going to have you write an equation right now using letters and numbers, okay? Just like I did. So on some scratch piece of paper, I want you to listen carefully, okay? You are going to write an equation of, I'm losing my whiteboard, whatever. Okay, here it is. I'm going to erase this. And so I'm curious, can you please write an equation with me right now, but first on your own, and then we'll check. I want you to write an equation. If we started with 10 pennies, I'm looking at my book to the side, and then we added 5 each round, okay? So you start with 10 pennies, and you add 5 each round. Please write an equation using a letter. So you start with 10, add 5 each round. Using a letter, just like we did with the started with 2 and added 3, okay? So you can pause this video and then come back when you're ready, okay? But remember, this is your model on how to do it, all right? Okay, welcome back. So if you started with 10 pennies and you added 5 each round, and you were using this model, you might have an idea of where you could replace the 3 and the 2 with these numbers, right? So if you did something along the lines of 10 plus, parentheses, 5 times r, and you wrote equals something, you would be correct, okay? Because that would work. You have the R for the rounds, 5 each round, 10 to start with. If you had it like equal over here to maybe like P, because it's equal to total pennies or pastas, and you put the equal sign in the beginning, you are correct. If you, and there's a lot of correct ways to do this. So if you then said, well, Miss Thompson, I did have it in the beginning, but I used maybe a T or a different number to say total. And then instead of doing 10 plus 5 times 4, 5 times R, sorry, I did 5 times R plus 10, like I added 10 at the end instead of the beginning, you would also be correct. And if you use different letters for R or different letters for T or P, you know it's still correct, because as long as it's close to the word that it represents, like, you're fine. Okay, so I hope you have some success with this, and if it feels confusing, definitely send Miss Crowder or myself an email, and we'll have a Google Meet with you to explain it, okay? Because it's just something you got to get the hang of. All right, so today what you're going to do is you're going to do page 513. Actually, yeah. You're going to do page 513 and 514 in your, just looking at my book. You do page 513 and 514 in your math book. You are going to write an equation using letters to represent the unknown, just like we practice right now. Okay, and that's the why we practice it right now, because Miss Karad and I want to see that in your work today. Okay, so I just said 513 and 514, so I'm flipping in my own book right now to see what that looks like. Yeah, so right here it talks about having, you start with 6 and you add 10. Oh, another mistake I was seeing a lot. I'm going to show you that right now, okay? Okay, one mistake I've been seeing in some students' work is where they have the start with, and they think about the start with as the first round. So if you start with 6, this is not round 1, because round 1 means you've added 10 one time. So this is like round 0. Round 1 would be this plus 10. So round 1 is 16. Okay? And remember, notice when you jump from 7 to 10, because it's not just going to be adding 10 more, you're going to need to use your equation. Write the equation using letters to represent the unknown, like we just practiced, and see if you can figure out this challenge about figuring out if 157 would ever be true. On the back, you're just going to practice this more. And actually, we just did this, so I'm going to say no to this. I changed my mind. You're going to do page 513 and you're going to do page 515. Okay? It's a little bit different because you're starting with 3 and you're adding 2. Okay? So like I said, 513, 515. Okay? This will be a challenge, and I'll go over it in the following day's lesson if it feels confusing to you, but everybody needs to try and show their work. Okay, good luck and have a great time.